In class, we've been talking about quadrilaterals, and in this video, we're going to talk specifically about a type of quadrilateral. Hopefully you remember that any polygon with 4 sides is a quadrilateral. However, some quadrilaterals have special properties. All these different quadrilaterals we're going to learn about have their own set of unique properties, and the one we're going to learn about today is called a parallelogram. And a quadrilateral with 2 pairs of parallel sides is a parallelogram. Okay, if we're going to name one, we name it using the vertices. So here's A, B, C, D, and we name it by saying parallelogram A, B, C, D, or we can draw a little parallelogram symbol, A, B, C, D. Either way is fine for naming parallelograms. Property of parallelograms is that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So when we look at this picture, we see that this is a parallelogram because up here it fits the definition. It has 2 pairs of parallel sides. Well, if that's true, then that means the opposite sides are congruent. So our conclusion would be that AB is congruent to CD and BC is congruent to AD. Again, this is a theorem that we could use in a proof or we could use to solve some of our problems. So if we see a parallelogram, we know that the opposite sides are congruent. A couple of other theorems: if a quadrilateral is a parallelogram, then the opposite angles are congruent. So in our picture here we have a parallelogram, and that implies that angle A is congruent to angle C, and angle B is congruent to angle D. Another theorem: if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now, consecutive means one right after the other, so A and B, or B and C, or C and D, or D and A, like that. So the angle and then the one that comes right after it. So we can say that the measure of angle A plus the measure of angle B equals 180. The measure of angle B plus the measure of angle C equals 180. Measure of angle C plus the measure of angle D equals 180. And I don't have room, but I'm going to write the measure of angle D plus the measure of angle A also equals 180. So basically it just means any 2 angles next to each other in a parallelogram add up to 180 degrees. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Now, diagonals are the line segments that go from opposite corner to opposite corner. Now, my picture is not perfect here, but they intersect, and when they intersect, the 2 pieces that are created are congruent to each other. So and let's say that this is point G. So AG would be congruent to GC. And also, these 2 pieces are congruent. So if the diagonals bisect each other, we could say here that segment AC bisects segment BD. And that would also let us say that segment AG is congruent to segment GC, and segment BG is congruent to segment GD. So parallelogram problems are pretty easy. Everything's the same as something else, or it adds up to 180 degrees. So if we take a look at our parallelogram here, it says parallelogram CDEF. DE equals 74. So DE right here is 74 millimeters. Then it says DG. So DG is right here, is 31 millimeters, and angle FCD, so FCD, that's this angle, is 42 degrees, right? That's this angle right here. And our questions are to find CF. So we look up here from C to F. Well, that's right here. And we know that because it's a parallelogram, the opposite sides are congruent. So that's also 74. Find the measure of angle EFC. Well, EFC is this angle. Well, we know that two angles next to each other, consecutive angles, are supplementary. So to find angle EFC, we can do 180 minus 42 is 138 degrees, and we got our answer. Find segment DF. Well, DF is from D all the way to F, so it's this whole segment here. And since we know the diagonals bisect each other, we know DG is 31, so the other one's 31. So 31 plus 31, 62. All right, here's another example. We have EFGH is a parallelogram. So when we look at this picture over here, we know that the opposite sides are parallel, the opposite sides are congruent, the diagonals bisect each other, lots of information. So find JG. Well, let's see, JG is right here. Well, it says W plus 8, and we don't know what W is, but we also see that EJ is 3W. And so 3W has to equal W plus 8 because, remember, these are bisected. Bisected means equal parts. So we subtract W, we get 2W equals 8, and W equals 4. Now, 4 is not the answer. Question said, what is JG? Well, JG equals W plus 8. So 4 plus 8 equals 12. And then we come to find FH. So FH is this entire piece, which we don't know how long it is and we don't know what Z is, but we know that 4Z minus 9 equals 2Z. So we're going to move things around to solve this problem. So I'm going to subtract 4Z, and I'm only doing that because if I move the 2Z, it'd leave me nothing on this side. Divide by negative 2, and I get that Z equals 9 over 2, right? Which negative 9 over negative 2 is positive. And so now the question was, what does FH equal? Well, FH is 4Z minus 9 plus 2Z. If we added both of those together, right, that's what it would equal. So that's 6Z minus 9. And I know that Z is 9 over 2. Well, 6 times 9 is 54. Divided by 2 is 27. And 27 minus 9 is 18. All right, on to our last example. This is all stuff we can do with parallelograms. So we have 3 vertices of parallelogram J, K, L, M are given right here. So here's J, K, and L. And it wants us to find the fourth one. So the easiest way to do this is just to put all of these points on our coordinate grid and figure out where the fourth one goes. So we have 3, negative 8 for J. We have negative 2, 2 for K. And L is 2, 6. And so what this problem is asking us to do, missed that one a little bit, is find out where the other side of this thing is, probably right out here somewhere, but we're not sure exactly where it is. You know, it'd be in this area somewhere. So we're going to figure it out. And the easiest way to do it is to see how much does this piece move, right? How much do we move from K to L up here? You see we go 1, 2, 3, 4, up 4, 1, 2, 3, 4, over 4. But what we really found when we did our 4 over 4 is we found our y2 minus y1 over x2 minus x1, which is our slope. And since we're working with parallelograms, we know the other side needs to go up 4 and over 4. So that's where our point would be to finish this parallelogram out. Not very straight, but You get the idea, and that point is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So M is 7, -4. And that's it. See you tomorrow.